Today we will discuss some quantitative aptitude questions of the geometry part. Okay, this is a quantitative comparison question. That means we have two quantities A and B. We have to calculate the values of both the quantities and then decide whether quantity A is greater, B is greater, both are equal, or the relationship cannot be determined from the information that is given in the question. Let's come to this question. Quantity A says length of the side of a regular pentagon with perimeter 12.5. We all know that a pentagon has 5 sides. So in order to calculate side of a regular pentagon, we will divide the perimeter that we have by 5, which gives us 2.5. This is our quantity A. Quantity B says the length of a side of a regular hexagon with perimeter of 15. We all know that a hexagon has 6 sides. So to find one side, we will divide 15 by 6, which gives us 2.5. Now we can see from this that quantity A is equal to quantity B. That means our answer to this question will be the two quantities are equal. Let's see another question. This question says that a line in the xy plane contains the following 2 points. We have a line in the xy plane, AB. Are those 2 points, and we are given the coordinates of A and B. The coordinates of A are 5, 4 and the coordinates of B are 2, -1. So in quantity A, we have to find the slope of the line. We all have already studied that the slope of a line is y2 minus y1 upon x2 minus x1. Let us substitute the values. Y2 in this case is -1, y1 is 4, x2 in this case is 2 and x1 in this case is 5, which gives us -5 upon -3, that is 5 upon 3. This is our quantity A. Quantity B, as we can see in this case, is 0. So we can say that quantity A is greater than quantity B. That means answer to this question will be option A, that is quantity A is greater. Let us see another question. In this question, we have a right angle triangle and we are given the value of the hypotenuse and the other two sides. So we all know that Pythagoras Theorem states that hypotenuse square is equal to the sum of the squares of the other two sides. That is what we have to do in this question. So let us first substitute a random value of y. Let us say that y in this case be 0. So the value of the sides in this case will be 13, 5 and 12. So if we calculate this, 13 square is equal to 5 square plus 12 square. This holds true. That means it is a Pythagorean triplet. In this case, we can easily say that x equal to 90. That means quantity A and quantity B is equal. That means if the value of y equal to 0, then x will be equal to 90. That means this will amount to option C. Now let us put some other value of y. Let us say the y be 1. If we put the value of y as 1, our sides will become 13, 5 plus 1, 6, 12 minus 1, 11. This is not a Pythagorean triplet. That means this particular equation does not hold true. That means in this case we can say that we cannot really determine the relationship between x and 90. That means substituting different values of y, we cannot be sure whether this triangle is a right angle triangle or not. So that means the answer to this will be D. The relationship cannot be determined. In this question, we are given a figure. We have a circle in which we have another triangle. Now says that in the figure, triangle RST is inscribed in a circle. The measure of the angle RST is greater than 90 and the area of the circle is 25 pi. So the area of the circle is given by pi r square, that is given in the question as 25 pi. That means r, that is the radius of the circle in this case, will be 5. We are also given that the measure of angle RST is greater than 90 degrees. That means we all know that in a circle the diameter subtends angle 90 degree. That means if this angle is greater than 90 degree, that means RT is not the diameter of the circle. Now let us calculate the value of the diameter. We know the value of the radius, that is 5. That means we can calculate the value of diameter, that is twice of radius, which will give us the value of 10. We all know that in a circle, the longest chord is the diameter. That means whatever be the value of RT, because it is not the diameter, its length will always be less than the diameter, that is 10. That means length of line segment RT will be anything that is less than 10. This is our quantity A. Our quantity B itself says 10. So from these two things we can easily deduce that in this particular question, quantity B is greater than quantity A. Okay, let us come to another problem statement. This question says that a construction company will produce identical metal supports in the shape of a right angle triangle with legs of length 3 feet and 4 feet. We have a right angle triangle with the lengths of legs 3 and 4. The three sides of each triangular support are to be constructed of metal stripping. If the company has a total of 6,000 feet of metal stripping and there is no wastage of material in the construction of these supports, what is the greatest possible number of supports that the company can produce? So it says that the arms, all the three arms of this particular triangle are made from metal stripping, and how many triangles can be made out of 6,000 feet of metal stripping. So for one triangle, by using Pythagoras theorem, we can calculate the third side, because it is said that it is a right angle triangle. 4 square plus 3 square will give you 25. That means this side will be 5. That means the total metal stripping that is required for one triangle will be 5 plus 4 plus 3, that is 12. So if we have to calculate the greatest possible number of supports that the company can produce, we will divide this 6,000, that is total feet, by 12, which gives us the value of 500. That means out of these 6,000 feet of metal stripping, we can make 500 such triangles. That gives our option as B. Okay, what is this question? This says that what is the area of a triangle ABC which is right angled at A? We have a right angled triangle. This measure is 30 degrees and we know the length of AB as 6. We know this is 90 degree, we know this is 30 degrees. So we can say that the value of angle B is 60 degree. Now we can say that this particular triangle is a 30, 60, 90 triangle. We have already seen the properties of 30, 60, 90 and 45, 45, 90 triangle. In this case, we have a 30, 60, 90 triangle. We know the value of the side that is opposite to the 30 degree side. We also know the ratio of the sides in this particular kind of triangle. The ratio is 1 is to root 3. We know the value of this corresponding one, that is 6, which is AB. So we can easily calculate this value, which will be 6 root 3. That means the value of AC in this case will be 6 root 3. Now, what do we have to calculate? We have to calculate the area of this triangle ABC. That means the area in this case will be half into base into height. Now we have the value of base, we have the value of height. It gives us 18 root 3, which is our value D. Okay. Let us see this question. This says that the volume V of a right circular cylinder is pi r square h. The volume of a right circular cylinder is pi r square h, where r is the radius of the base and h is the height of the cylinder. if the volume of a right circular cylinder is 45 pi and its height is 5, we have to find the circumference. This volume is given as 45 pi and the height is also given as 5. Let us substitute the values. Height is given as 5 pi, we do not know the value of r square, height is 5 which is equal to 45 pi. From this we can calculate the radius, that will be under root of 9, that is 3. Now we have to calculate the circumference of the base. The formula for circumference is 2 pi r, that is the circumference of the base of the right circular cylinder, that is 2 into pi into 3, that will give us value as 6 pi. In this question we have a figure in which inside a square we have a circle and then inside this circle we again have a square inscribed. Let us see what the question says. The question says that in this figure, if the square inscribed in the circle has an area of 16, what is the area of the shaded region? So we know that the area of this square is 16. That means if we take the side of the square as a, we can say that a square is 16. From this we can conclude that the value of a is 4. Now we have to find the area of the shaded region. Let us draw this figure. Now we know that this particular side, that means every side of the square has value 4, and so the diameter will have a value of 4 root 2. That means the diameter of the square is equal to the diameter of the circle. So we can say that the radius of this particular circle is 4 root 2 by 2, that is 2 root 2. So we can calculate the area of the circle. Area of the circle in this case will be pi r square, that means pi into 2 root 2 square, that means 8 pi. Now we have the value of the circle. What will be the value of this particular shaded region? If we subtract the area of the square from area of the circle, we will get this part, this part, this part and this part, and if we divide this entire area by 4, we will get one particular segment. That is exactly what has been asked in the question. Now let us subtract the area of the circle, that is 8 pi, from the area of the square, that is 16. So if we divide this particular value by 4, we can find the area of this particular shaded region, that is 2 pi minus 4, which corresponds to option B. भैया